Hello all, welcome back to Sri Sai Tech Edu YouTube channel, Read, Lead, Success. I am dealing with the subject and network analysis and control systems. In that already module 1 videos have been uploaded. In module 2, I have started with the two-port networks. In that we have seen many of the topics. Today we will see one of the topic in this video. We have already done with one port network, admittance parameters, some equivalent networks, impedance parameters. We will study now today a new parameter, that is transmission parameters. Transmission parameters. These two port parameters are just called T parameters, the ABCD parameters, or simply the transmission parameters. This transmission parameters can be called as T parameters or transmission parameters or ABCD parameters. Any of the three are seen. They are defined by, for a two-port network, V1 is equals to T11 V2 minus T12 I2. And I1 is equals to T21 V2 minus T22 I2. So we can write in the matrix form, that is V1 I1 is equals to T into V2 into minus V2 and minus I2. The current is minus I2. The minus sign that appears in the equation should be associated with the output current as minus 2. Thus both I1 and minus I2 are directed to the right, the direction of the energy of signal transmission. What they are telling is, usually in a two-port network, for example this is a two-port network, for example we write I1 in this way and I2 in this way, right? But in transmission parameters, the I2 also is in the right direction. I2 is also in the right direction. Means the output current I2 is also in the right direction. So we are writing it as minus I2. Output current minus I2. Okay. Then other widely used nomenclature for this parameter is ABCD parameter. As I said, T11, T12, T21, T22. It can be written as ABCD parameter. There is no minus sign in the ABCD matrix. If you are writing in the ABCD matrix, no need to mention the minus sign. But here it is minus I2. Okay. Here we have illustrated one possible procedure where for finding a single parameter, we consider one of the single parameter. I will show how to do. T12 is equals to V1 by minus I2, that is V2 equals to 0. Nothing but we can short this V2. Here what it is shown. And if you see here minus I2, the direction is right side itself, but you are taking as a minus I2. Then the equivalent resistance offered to the 1 volt source is R equivalent. Then these two are in parallel, in turn series with plus 2, and apply current division rule here. You will get as minus I2 as 5 by 34 amperes. Then T12 will be equals to 1 by voltage V we have took as 1 volt. So 1 by I2 minus I2. I2 is 5 by 34. The 34 will go to the numerator. So 34 by 5 we get as 6.8 ohms as the T12. Okay, it should be ohms only. No, why? Because see, T12 is V1 by I. V by I is what? Resistance. So 6.8 ohms is the T12 value. This is one of the parameter. We can find the other parameters also. Just for example, one of the parameter I am showing here. Terminal voltage and currents are indicated for each two port, and the corresponding T parameter relationship are for network A. What they are showing is, there is a two network which is in cascaded form. Then the T matrix T, the total T is nothing but product of T and TB. They are telling how it is, we will see. For network A, the equation can be written as what? V1 I1, that is equals to TA into V2 and minus I2, right? Then that is equals to TA into this, that is equals to TA into V3 into I3. We can write. Then for network B, V3 I3 is equals to TB into V4 and minus I4 we will write. But we know that V3 into I3 is what? Here what we can substitute? V1 I1. Then In the place of V3 I3, what we can substitute here? This TB into V4 minus I4. So TA into TB into V4 minus I4 will be the final equation, matrix equation. Therefore, the T parameters for the cascaded networks are found by the matrix product. Nothing but the total T is nothing but TA into TB. The total matrix T is TA into TB for the whole cascaded circuit. What this proof means? Nothing but what we are writing is for network A separate T and for network B separate T parameters will find. Then multiply these two both, will get the total T, what it means. Okay, total T parameters can be found. In the sums, if you will understand much more clear, this is the concept. We will see sums now. Find the T parameters for the cascaded network shown in figure. If you see here, there is two networks, network A and network B. How to find T parameters? For network T A, we will find parameters, and network B will find T parameters. Then multiply those two matrices, then we will get the total T parameters. We will see how. See, first you will consider this network A. Considering this network A. Then take two meshes, I1 and I2 currents. Apply KVL to mesh 1 and mesh 2. If you apply mesh 1 mesh analysis to the first mesh, then you will get V1 is equals to 12 I1 plus 10 I2. For second mesh, when you apply KVL, you will get as V2 is equals to 14 I2 plus 10 I1. From this, if you see, 10 I1 is equals to V2 minus 14 I2, and I1 is equals to 0.1 V2 minus 1.4 I2. If you see, this is in the form of T parameters matrix. That is, I1 is equals to T21 V2 minus T22 I2. Okay. So we got two parameters of T. That is for network A. Now we will see. Then therefore, V1, if we apply this I1, if you put this, substitute this I1 in this equation, then what we will get? V1 is equals to 12 into 0.1 V2 minus 1.4 I2 plus 10 I2. Then you will get as, what you will get? 1.2 V2 minus 6.8 I2. That equation, how it is looking for you, that equation, it is looking like V1 is equals to T11 V2 minus T12 I2. So consider T parameters. If you consider this and this, comparing with these two equations, you will understand how. See, V1 is equals to T11 V2 minus T12 I2. Nothing but T11 is 1.2 and T12 is 6.8. Then if you compare I1 equation, that is B equation, with this, then T21 is 0.1 Simon, T22 is 1.4. We can write. We have made question that Ohm, Simon, for this no units. Why? See, T11 is V1 by V2. So V1 by V2, both voltage cancels, so nothing, no unit for this. Then for T12, it is V1 minus I2. So it is V by I. So ohms is the unit. Then T21, I1 by V2. So I1 by V2 means Simon. Simon is the unit. So for T22, I1 minus I2. So both are currents and unit is same. Both get cancelled, so there is no unit for T22 also. You need to write the units, otherwise even for units also marks will be gone. So units is compulsory. Then the total TA you got as 1.2, 6.8, 0.1 and 1.4. The same way we will find for TB. For network B, we will write the mesh currents and write the mesh equations. First mesh equation is V1 is equals to 24 I1 plus 20 I2, and second mesh equation is V2 is equals to 20 I1 plus 28 I2. And from the second equations you can clearly see that it is in the form of V2 and I2 and I1. So if you take the V2, I1 and I2, so if you take this 20 I1 on the left hand side and others on the right hand side, Then what you will get in the terms of I1? I1 is equals to 0.05 V2 minus 1.4 I2. So you got one of the two parameters of the T, that is T21 and T22. So for T11 and T12, what we need to do? We need to substitute this I1 in the first equation. So you need to know the parameters so that you can easily manipulate the equations as you wish. See, V1 is equals to 24 into 0.05 V2 minus 1.4 I2 plus 20 I2. This equation only we have substituted the I1 value. So we want in which form? V1, V2 and I2. So V1 is equals to 1.2 V2 minus I2. See, so these two parameters, 1.2 is T11 and 13.6 is T12. So the TB matrix is 1.2, 13.6 ohms and 0.05 Simon and 1.4 is the TB. So if you want total T parameters, what I told we should do, we need to multiply the two matrices. Multiplying, how we will do? Row and column. 1.2 into 1.2 plus 6.8 into 0.05. In the same way we will calculate for others also. Calculating the matrix matrix multiplication, you will get T as 1.78, 25.84 ohms, 0.19 Simon and 3.32 is the T parameters of the two networks in cascade. If there is cascade, separately we need to find T parameters for individual networks, then multiply those both, we will get the total T parameters of the network. Given T parameters, they are given the T parameters, they are telling us to find the Z parameters and T for two identical networks in cascade. First you need to find Z parameters, then for the same T network, we need to find the identical networks, nothing but we need to multiply T into T, the same T parameters twice we need to multiply the same matrix, then you will get cascaded network, then Z for two identical networks in cascade. Z for two identical networks in cascade is nothing but whatever T you got in cascade, no, you need to convert into Z parameters. We will see how to solve this. First, you will write the T parameters equation from the matrix. How we know that? We know that what is the formula? V11 is equals to T11 V2 minus T12 I2. Then I1 is equals to T21 V2 T21 V2 minus T22 I2. So you know this. So when you know this, what you can do, you can write the T parameters which are in the form of matrix in the equations. Nothing but V1 is equals to 3.2 V2 minus 8 I2. Then I1 is equals to 0.2 V2 minus 4 I2. Then what we need to do? We want in the first one is Z parameters you want. Z parameters, you know that V1 is equals to Z11 I1. I think I have written already in this answer. See, you want Z11 I1 plus Z12 I2. So you want in the terms of V1, I1 and I2. How you will get? If you see the first equation, V1 is equals to, in the place of V2, if you substitute the equation from V2 here, from the equation 2, if you write I1 plus 4I2 by 0.2 and substitute in this V2, then what you will get? You will get the equation in terms of V1, I1 and I2. See, V1, I1 and I2. Initially it is in the form of what? Initially it is in the form of V1, V2 and I2. What we want? V1, I1 and I2. So we have substituted the V2 equation so that it is in the form of I1, I2. If you substitute in this, you will get V1 is equals to 16 I1 plus 56 I2. V1 is equals to Z11. Z11 is 16, Z12 is 56. Then if you substitute, then you can see that in the second equation, 0.2 V2. We want next equation as V2 is equals to Z21 I1 plus Z22 I2. So in this, if you take V2 on the left side, V2 is equals to 5 I1 plus 20 I2 you will get. How? 0.2 V2 is equals to I1 minus 4 I2 will be going to left side. So that is plus 4 I2. So V2 is equals to 1 by 0.2 is 5I1, 4 by 0.2 is 20I2. So you will get Z21 as 5 ohms and Z22 as 20 ohms. So now you got Z11, Z12, Z21 and Z22. So you can write the matrix. So first question is done. Now second question, what they are asking. They are asking T for identical networks in cascade. So T parameters already is given. They want the identical networks in cascade. So multiplication of the given T matrix, it will give you the answer. So if you multiply this both matrices, then you will get 11.84, 57.6 ohms and 1.44 Simon and 17.6 as the T parameters. Okay, then what we have? Second question is done. The third one, what they are asking, Z for two identical networks in cascade. They want Z for two identical networks in cascade. Now already we found the cascaded equation, identical equation. For this we need to find the Z parameters. Nothing but we are converting T to Z. How we can write? We know T parameters equation. How we can write it? V1 is equals to 11.84 V2 minus 57.6 I2. Then I1 is equals to 1.44 V2 and 17.6 I2. Nothing but we are writing the matrix in the form of T parameters equation. Then from 2 take V2 and substitute in 1. From the second equation take the V2 in terms of V2 and substitute in 1. So that you will get in the form of V1 is equals to some Z11 I1 plus Z12 I2. What is that? 8.22 I1 plus 87.1 I2. You got one Z11 and Z12. So if you substitute now, no need to substitute. The second equation, if you see, we have V2 and I1 and I2 already in the equation. So if you take 1.44 V2 on the one side and this plus minus 17.6 I2 on the left side, then what you will get? V2 is equals to 0.694 I1 plus 12.22 I2. So now you got Z21 and Z22. So what the question they asked, that is Z for two identical networks in cascade. Already two identical networks in cascade we found in B answer. From that we need to convert it into Z. That's it. Easily we can convert from one parameter to other parameter if you know the parameters equations, like these equations. What I am writing here, no, you need to know which parameters has which equations. So you can directly convert from the KVL, KCL if you applied, or from the equations you can directly take whichever values you want. By just substituting you can find the accordingly the which parameter values you want. And next, determine the ABCD matrix which represents the two ports shown in figure. See what they are asking. ABCD is nothing but transmission parameters only, or T parameters. It is easy. What we can do, we will consider the KCL. So it will be easy. Consider this as V1, this as V2, and write the KCL to node 1. I1 is equals to V1 by 5. If this is incoming current, this will be outgoing current and this will be outgoing current. V1 minus V2 is equal by 10. So you will get the equation as I1 is equals to 3 by 10 V1 minus V2 by 10. Then apply KCL to node 2. What you will get? I2 is the incoming current and this will be outgoing current V2 by 10 and V2 minus V1 by 10. If you don't know KCL, KVL, mesh analysis, that is nothing but mesh analysis and node analysis, there is a separate video I made which is of the module 1. You can go and check out. I2 is equals to minus V1 by 10 plus 3V2 by 20. So from this equation you can see that what we want T parameters. So T parameters will be in the form of what? V1 and I1. So V1, from this what we can do, minus V1 by 10 is equals to I2 minus 3V2 by 20. So after calculating, what you get, V1 is equals to 3 by 2 V2 minus 10 I2. You got two parameters, that is T11 and T12 easily. Then if you want T21 and T22, what we can do, substitute this V1 in equation 2. So you can easily get, that is, sorry, not equation 2, substitute V1 in equation 1. So you can get easily. How? See, I1 is equals to 3 by 10 into V1 is this if we have substituted minus V2 by 10. So I1 is equals to 350 milli V2 minus I2. Nothing but we want in the terms of what? V1 is equals to T11 V2 minus T12 I2. Then I1 is equals to T21 V2 minus T22 I2. So you got both the parameters. Just the conversion and substitutions. That's it. You should know the main equation. This main equations, if you know, it is very easy to substitute and find the values. T is equals to 1.5 and 10 ohms and 350 milli Simon and 3. It's the ABCD matrix for the given network. Two networks are represented with the following impedances matrix. Determine the T matrix which characterizes the cascaded network resulting from connecting network 2 to the output of network 1. Reverse the order of the networks and compute the new T matrix. What they are nothing but telling is they have given Z1 and Z2. We need to find the T matrices for the both. That is by cascading. T matrices, that is network 1 to network 2 and network 2 to network 1. First, initially we will convert Z1 to T1 and Z2 to T2 matrix. Now let me tell you how. Z1 is equals to 4.7, 0.87, 0.5 and 1.8. You know that Z parameters equation is V1 is equal to Z11 I1 plus Z12 I2. V2 is equal to Z21 I1 plus Z22 I2. Write the matrix in that form, that is V1 is equal to 4.7 K plus 0.5 K I2. V2 is equal to 0.87 K I1 plus 1.8 K I2. From this equation, from the second equation, you can see that I1 is equals to V2 minus 1.8 K by 0.87 K. You can do. From that, you can get I1 is equals to 1.15 milli V2 minus 2.07 I2. So, which if it is in the form of what? I1 is equals to T21 V2 minus T22 I2. Why? Because I1 V2 I2 it is in the equation is in the form of I1 V2 and I2. So we can say that T21 is 1.15 milli and T22 is 2.07. So now we are left with T11 and T12. How to find that? Just substitute this I1 value in the equation 1 so that you will get V1 is equals to 4.7 K into I1 1.15 plus into 10 power minus 3 V2 minus 2.07 I2 plus 0.5 K I2. If you calculate this, you will get V1 is equals to 5.40 V2 minus 9.22 K I2. So V1 is equals to T11 V2 minus T12 I2 also you got the T1 network matrix. Now we are left with, we need to find T2, that is for Z2 we need to find the T parameters. Z2 is equals to, how you can write, V1 is equals to 1.1 K I1 plus 2.2 K I2. V2 is equals to 0.89 K I1 plus 1.8 K I2. These are the Z parameters. We need to convert into T parameters. In the same way what we have done for the network 1 for Z1, we will do the same. That is, from the second equation you can see that I1 is equals to V2 minus 1.8 K I2 by 0.8 K. So you will get in the terms of I1 is equals to T21 V2 minus T22 T22 I2, T22 T21 V2 minus T22 I2. This is not there, T22 I2. Then V1 is equals to, you can substitute this I1 value in the first equation. Where is the first, in this first equation? So you can easily get what? V1 is equals to 1.24 V2 minus 0.024 K I2. So V1 is equals to, you will get in the form of T11 V2 minus T12 I2. I'm separately calculating, okay. This is for, from here Z2 start, from here Z1 start from here, Z2 starts from here. So for Z1 first and second equations are separate, and for Z2 first and second equations and A and B equations are separate. Don't get confused. If you want, you can mention them as third equation, fourth equation, like that also. It is your wish. Then T2 equation also you got. T1 you got, T2 you got. What they are asking? When one network is connected left and another network connecting right in cascade, and reverse the order. Nothing but T is equals to T1 into T2 and T is equals to T2 into T1. They are asking. First we'll multiply T1 with T2. You will get as 17.05, 1.87 into 10 power 4, 0.04 Simon and 4.2. Then if it is reverse order, then T2 into T1 you will do 6.67, 1.14 into 10 power 4, 8.26 into 10 power minus 3 Simon and 1.43 as the value. See, the network given here is the two-port of figure can be viewed as three separate cascade. Two ports, that is A, B, C. Compute T for each network. Obtain T for cascading network. Okay. Simply what we should need to do here is find T for A, B, C and then multiply TA into TB into TC. You will get the network. That is nothing but T parameters. That's it. See, first for network A we will consider what is the network A? 1 ohm, 2 ohm with the I1, I2 and I1 and I2 as the mesh currents. Applying KVL to mesh 1 and mesh 2. So by applying KVL to mesh 1 you will get V1 is equals to 3I1 plus 2I2, and for mesh 2 you will get as V2 is equals to 2I1 plus 2I2. So I1, from the second equation you can see I1 is equals to V2 minus 2I2 by 2 if you write, then you will get I1 is equals to 1 by 2 V2 minus I2, which is in the form of I1 is equals to T21 V2 minus T22 I2 in the form of what? T parameters equation. Substitute this A, that is I1, in equation 1 so that you will get the T11 and T12 also. So V1 is equals to 3 into I1 is what? 1 by 2 into V2 minus I2 plus 2I2. Then you will get V1 is equals to 3 by 2 V2 minus I2. So V1 is equals to T11 V2 minus T12 I2, because this is in the form of T parameters equation. You need to know the parameter equations of all the parameters. Then only you can substitute and you can understand. Otherwise you can't understand. You just feel like I am just reading the things. But if you know these parameters only, you'll understand. So better write the parameters one side, so that it will be easy for you to remember the parameters and find. Okay. Then so TA you will get as this is as the matrix. In the same way we will find for TB and TC. For TB, consider this network 3, 4. Same way you will apply KVL to mesh 1 and mesh 2. You will get V1 is equal to 7I1 plus 4I2. And KVL to mesh 2, then V2 is equal to 4I1 plus 4I2. So from this you can take I1 is equal to V2 minus 4I2 by 4. Why we are taking this is because you will get the T11 and T21 and T22 values from this equation. Why? Because I1 is equals to T21 V2 minus T22 I2 it is. So from this you can get as I1 is equals to T21 as 1 by 4, T22 as 1. So then this, if you substitute this I1 in first equation, then you will get V1 is equals to 7 into I1 is what? 1 by 4 V2 minus I2 plus 4I2. If you substitute, you will get V1 is equals to 7 by 4 V2 minus 3I2. So 7 by 4 is T11, 3 is T12. So you got the second matrix also, TB matrix. Then now we will find the TC matrix. To find CC matrix, same again. Apply KVL to this mesh. The C network you consider. For the first KVL mesh equation, what you will get? V1 is equal to 11I1 plus 6I2. V2 is equal to 6I1 plus 6I2. From this, you consider the I1. If you consider I1 is equal to 1 by 6 V2 minus I2, which is in the form of I1 is equal to T21 V2 minus T22 I2. So you got T21 and T22. For if you want T11 and T12, you need to substitute this I1 in equation 1. You will get V1 is equals to 11 into 1 by 6 V2 minus I2 plus 6I2. So V1 will be equals to 11 by 6 V2 minus 5I2. So it is in the form of V1 is equals to T11 V2 minus T12 I2. So we got the third TC network T matrix also. They are asking in the second question as obtain T for the cascaded network. How to find T is equals to TA into TB into TC. Just multiply all the matrices what we got for A, B, C. Then you will get the value as, first you multiply first two matrices. How to multiply is, You can either use calci also for multiplying it. 1, 2, you'll multiply, you will get this. This will multiply with this, then you'll get 6.19 and 19.88 ohms and 2.48 Simon and 8.12 as the T matrix for the given network. Determine the T parameters which describe the two-port of the figure. If you see this figure, you should need to find the T parameters for this. It's easy. We'll see how. Apply KVL to mesh 1. By applying KVL to mesh 1, if you see here clearly that we'll consider from plus to minus every time. No, this is one mesh current. If you see the current here moving is in this direction, the other dependent current source. From in 5 ohm source, if you see the currents are in opposite direction. So I1 minus the other current is 0.8 V2 into the resistance 5 ohms, that is equals to V1. The V1 across this is equals to I1 into R. I1 is what? I1 minus 0.8 V2 into R is what? 5 ohms. That's it. Then you will get V1 is equals to minus 4 V2 plus 5 I1 as the first equation. Now we need to apply KVL to the mesh 2, whichever is present. So V2 is equals to V2 minus 2 I2 minus 0.1 I2 0.1 V1, that is equals to 0. If you see from this, V1 is equals to, if you substitute these values, we want T parameters. So V1 is equals to 10 V2 minus 20 I2 you can do by rearrange the things. Nothing but V1 is equals to T11 V2 minus T12 I2 you will get. Then if you substitute this V1 in the first equation, then you will get T21 and T22 also. How? Substitute V1 in first equation. V1 is equals to minus 4. V1 value is what? And V2 minus 20 I2 is equals to minus 4 V2 plus 5 I1. Then you will get 5 I1 is equals to 14 V2 minus 20 I2. So I1 is equals to 14 by 5 V2 minus 4 I2. So this is in the form of what? I1 is equals to T21 I1, T21 V2 and T22 I2. So you got T11, T12 and T21 and T22. So this is the matrix T parameters for the given equation. You need to know the parameter equations, then only you can do. You need to know KVL or KCL, then only you can find the equations. From that equations you can do substitutions and rearranging, so that rearranging should be same as like T parameters equations, that is these equations. Then only it is for all the parameters. I'm not telling for only T parameters, like maybe it is for impedance parameters, then admittance parameters, whereas it is T parameters. In future you will learn next as H parameters. Everywhere you need to know the parameter equations, then only you can solve. Three identical networks as one directed are cascaded together. Determine the T parameters which is fully represent the result. Nothing but what they are telling us. First, we need to find the T parameters for this network. Then multiply the T parameter matrix 3 times. That is identical 3 networks in cascade form. So the same network 3 times it is connected in cascade. How it is, you know, if this is the thing, again it is connected. Again it is connected. Like this, in this form, 3 networks, the 3 parameter same, the identical, that is 100, 150 to 25. Like this 3 times the given network is connected. So need to find the T parameter for that cascaded. So if you find only once the T parameter, enough. You can, the same matrix you can multiply 3 times so that you will get the T parameters. First we'll consider I1 and I2 currents, apply KVL to mesh 1 and mesh 2. We'll get V1 as 125 I1 plus 25 I2 and V2 as 25 I1 plus 75 I2. Then from this, you know, from the equation 2 what you will do, we'll take the I1. I1 is equals to V by 25 minus 3 I2, which is in the form of T21 V2 minus T22 I2. So substitute this I1 in equation 1. Equation 1, V1 is equals to 125 I1. I1 is what? V2 by 25 minus 3 I2 plus 25 I2. If you substitute, you will get the V1 is equals to 5 V2 minus 350 I2. So V1 is equals to, it is in the form of T11 V2 minus T12 I2. So you got now T11, T12, T21 and T22. So if you multiply this T 3 times, then you will get 307, 2.2 into 10 power 4 ohms and 2.52 S and 181 as the total cascaded together 3 identical networks of the given network. T parameters. That's it. See, this question is little interesting. Find T parameters for the network. Only one resistor is present with a parallel or which is connected with a just a wire. As I told, it can also be called as ABCD parameters. See, the equation can be written as V1 I1, V2 I2. In between the matrix is ABCD. From this, what you can write, A is equals to V1 by V2 when I2 is equals to 0. Then B is equals to V1 by I2 when V2 is equals to 0. Then C is equals to I1 by V2 when I2 is equals to 0. D is equals to I1 by I2 when V2 is equals to 0. You can write in this way equation. Okay, if you are getting confused, just see V1 is equals to A, if you multiply A into V2 plus B into I2. From this what we can write? See, A is what? V1 by V2 when I2 is equals to 0. Okay. Then for B, V1 by I2 when V2 is equals to 0. I think from equations you can easily understand and matrix. Then we will see for C and D. I1 is equals to C into V2 plus D into I2. From this you can see that C is equals to I1 by V2 when I2 is equals to 0. Then if you want D, I1 by I2 when V2 is equals to 0. See which parameter you want, that parameter, this by that parameter I2 value we need to divide. So the other parameters V2 or the current will be 0. Okay, like that you need to write. I hope you understood. Even for the previous parameters also I told how to write this, where for one parameter what is the equation or the formula. So for the step 1 what we need to do, we'll make I2 is equals to 0. These two equations, we'll get A and C. When I2 is equals to 0, there is no current flowing through the resistance R. What it means, when I2 is equals to, there is no current only in the this. So there is no flowing current to the resistance R. So V1 will be equals to V2 and I1 will be equals to 0. Why? Because then I2 is equals to 0. So V1 equals to V2 means what? 1 by 1. So V1 is 1, I1 V2 is 1. So A equals to 1, C equals to 0. Why? Because I1 is 0. Okay. Now we got A and C. Now what we will make? Short circuit. The short circuit test where V2 is equals to 0. See, whenever current we will open circuit, whenever voltage we short circuit. So V2 is equals to 0 means we will short circuit this V2 side. Okay, when V2 is equals to 0, the resistance is shorted, meaning V1 will be equals to I2R. See, V1 will be equals to I2R. I1 will be equals to I2. See, when V2 is equals to 0, the two currents will be equal. I1 will be equals to I2. So, V1 will be equals to what? Either I2R you can write or I1R you can write. Okay, you can write both. V1 is equals to I1R or V2 Y1 is equals to I2R. So, from this you can write B is equals to R. Why? Because V1 by I2 is R. And for D, I1 and I2 is same, so D equals to 1. So you got the T parameters for the simple network as 1R01. These are the practice questions on the transmission parameters. These are very easy. These two questions you can solve. This similar type I've already solved in the previous slides of the same topic only. So it's very easy. Apply KVL to both sides. Apply KVL to both sides. You can easily get the T parameters by just substituting the things. So now we are done with one port network, admittance parameters, some equivalent networks, impedance parameters and transmission parameters in this video. So I'll stop the video now with the topic transmission parameters. Then we'll continue with the hybrid parameters with a new video in the next video. So I'll stop the video till the transmission parameters now. We are only left with hybrid parameters to complete the module 2 first chapter, that is two-port networks. Thank you. From Sri Sai Tech Edu YouTube channel, Read, Lead, Success. Keep reading.